the EIGRP Stub Router. So this stub router, students, we can configure an EIGRP router as a stub router. What are the characteristics of this stub router? The stub router will announce to all its neighbors' neighbors that it is a stub router. This message announces that it is a stub router. This message means that the stub router cannot become a target of queries. It will not become a target of queries. Students, what does stub mean? It means boundary. So if we turn a router, an EIGRP router, into our EIGRP stub router, then it's quite simple. What I mean is, this is the meaning. Let me draw a diagram for the students. For example, we have talked about regarding our EIGRP queries. There's an R2, an R3, and an R4, R1 announced a route for 1.1. 1.0/24 on R2's side, 1.1. 1.0/24. The next is R1 on R3's side, 1.1. 1.0/24. The next is R2 on R4's side, 1.1. 1.0/24. The next is R3. In the last lesson, we talked about the final aspect of the EIGRP query mechanism, which is what we demonstrated earlier. If this routing entry, the next hop, is the router sending such a query message, for instance, then R1. Then I have lost a routing entry, I go to send a query, R2 finds that, the next is U, I won't reply, I continue to send a query further. 3 finds that, the next is U, I continue to send queries further until the boundary of our network, So what is a boundary router? What does it mean besides you, my EIGRP neighbor? I don't have any other EIGRP neighbors. Besides you, my EIGRP neighbor, I don't have any other EIGRP neighbors. So I have no other neighbors that can access this network segment. It's impossible for me to have access to this network segment. Because I have no other routes, I simply have nowhere else to go. I only have this one route to access. No other paths to access the routing entries you are querying. It's useless to ask me because I am the boundary of our network. There's no need to query me at all. So what does a stub router mean? It just means I directly make myself obvious. I just tell you, I am a stub, I am a boundary router. I definitely have no other paths. It's a waste of effort to look for me. I can't possibly have any other neighbor relations that let me access this network segment. It's a waste of effort to look for me, students. So the so-called stub router just tells you, I am a boundary router. There's no need to come to me, I definitely can't reach there. It's just that simple and blunt. So, the first feature of a stub router is that I won't become a target of queries. I just told you I am the boundary. Of course, this stub router doesn't necessarily have to be configured on an actual boundary path. Of course, I can also make a router in the middle of the network become a stub router as well. This stub router is an identity, so you can make a router consciously become a stub router. When I realize, after I receive a query message, then I have no other EIGRP neighbor relations. I know I am the boundary of our network, so I directly reply with a reply. This is it consciously becoming a stub router. So I reply with a reply message. Then this router can no longer reach, so we can designate it as a stub router. Then I become a boundary router. Just pretending to be a boundary router. You sending query messages to me is unnecessary. I have no other routers, I just pretend. I have no other EIGRP neighbors. You querying this routing entry from me is useless. You don't need to query me. A stub router will not become a target of queries. This is using what we talked about earlier. The third condition, the third query mechanism, to point out to us, or to lead us to this solution and make our router a stub router. In this way, we will not receive query messages anymore. So the routing entry you come to query, I directly tell you it can't be reached, or you just don't come to query me at all. Students, let's conduct an experiment to see. Now suppose we remove the summary. We delete all our summaries on the R1 side, restore the results first, our interface range loopback, 100 to 101. Sorry, so I've been hitting Huawei equipment a lot in the past few days. Interface range, loopback 100, 101, interface range loopback. Wait a moment, 100 to 101, shutdown, sorry. The other day we weren't running a Huawei course. We did an experiment, got used to hitting a lot, because Huawei's interface range, unlike Cisco's range, you can say interface range, like loopback, 100, 101, loopback 101. You can use a comma to separate multiple interfaces. You can also use a dash to 101. You can also use a comma with a dash, like dash 101, loopback, like 100, loopback 110. You can write it this way. But if you're on Huawei equipment, it doesn't have this kind of dash. You need to write something like loopback 100, then true loopback 101, loopback 101. It's a bit more complicated to write. You can't use that style, it's a bit annoying. You might have gotten used to it before. So now we do this, remove the summary, we skip the summary, now we do this, make our R2 become such a stub router. Then it won't become a target of queries. This is its first feature. We can directly cut our originally very large query range down to our R2 side. Wait a moment. Then when it stabilizes, the convergence is over. There are no EIGRP summaries anymore. Now we do this, make an EIGRP router, configure it as a stub router. It's very simple. In the EIGRP process, in one word, EIGRP stub, done. So directly configure our device to be set up as an EIGRP stub router. Alright students, now that we do this, after the configuration is completed, we will look at the command line. Show running config, we have taught you the pipe service, section router EIGRP. Directly see our router EIGRP part of the configuration. So you see, we directly typed EIGRP stub, turning our router into an EIGRP stub router, after which it added two more parameters, one connected, the other summary. These two parameters are related to another feature of our EIGRP stub router. Let's first look at its first feature. We will not become a target of queries. This feature is very simple. We turn on this between R1 and R2, for example. Currently, hello packets are being sent. Next, we do this. If now, seeing that EIGRP is configured as a stub router, we find that between the two, it actually directly reset our EIGRP neighbor relationship. Our EIGRP neighbor relationship is re-established. Think about it. Even if we previously, even through summarization, even if we invoked a policy, routing entry filtering, we never reset the neighbor relationship. But once it becomes a stub router, it resets the relationship. Why? Because we see this statement. So we directly announce to all neighbors that we are a stub router, this message. When we turn the router into a stub router, firstly, our hello packets change. In the EIGRP hello packets, we've added something new. Look, this is R1's hello packet. Then look at R2's hello packet, see what's added. It includes a peer stub information. It's simple. In my hello packet, I tell everyone, guys, I'm a stub router. I'm the boundary now. If you lose routing entries, don't come to me. It's useless to come to me because I am now a boundary router. You guys should not send me query messages. This is our stub information. Once we turn a router into a stub router, I will announce it widely. Then, if at this moment R1 loses its successful route, it definitely needs to send a query message. Let's see now what R1 is losing. We go directly to disconnect our own loopback 100 interface corresponding to the loopback interface, thus losing our directly connected route, which is this unique, our own originated successful route. Hello 1. After losing the route, you see there's no query. Students, we now, after losing our successful route, we directly find no other neighbors. With respect to you, R2, I will not send query messages to you, R2. Because I know you are the boundary now. You simply cannot reach the routing entry. You simply do not have any other path for the route. I won't check with you. I have other neighbors. I'll send it to other neighbors. Anyway, not to you. Because you are a boundary router. Students, of course, if I have other neighbors, of course, I will send it to other neighbors. This is our query. The first feature of a stub router. It will not be a target of queries. It will not become a query target. This is actually very easy to understand. The difficulty lies in the second point, stub routers. What did they give us in the command line? They sent an EIGRP stub. We sent two words, something called connected and another thing called summary. These two things, students, actually in our routing information, we can see what connected means. It means directly connected routes. And what summary means. It refers to summarized routes. Right, students? So when we configure a router like R2 to become a stub router, it will include one or two features, or say two features. The first feature is that we will not be queried. The second feature, then, allows us to automatically filter routing entries. Automatically when the router becomes a stub router, it will directly default to pointing towards neighbors, announcing its own self-originated directly connected routes and self-originated summarized routes. Students, what does this mean? Students, because if we assume, now let's take R3 as an example, I am the boundary router of our network. What's behind me? Behind me are hosts. Hosts, like for example, behind is the 192.168, 1.0/24 network segment, turning into a switch. Many hosts behind the switch. One host, two hosts, three hosts. So, as the boundary router of our network, do I not have any other EIGRP neighbors? This is the first feature, certainly no other EIGRP neighbors. I simply do not need to unnecessarily announce routing entries anymore. This is the first point. Then, I simply do not need to announce routing entries anymore. I am the boundary. I just need to do what? I just need to receive the routing entries announced to us from above. For example, the 100.1. 1.0/24 route. I go through R2 to receive routing entries. I am a boundary router, and behind me are some access devices, access hosts in this 1.0 network segment. I simply do not have any other EIGRP neighbors. I do not need to announce routing entries anymore. But right? Then I definitely need to do this. I definitely need to tell you about my directly connected routing entries. Otherwise, right? You, R2, if we, R3, don't announce our directly connected 192.168, 1.0/24 route, then where would R2 get the 1.0/24 directly connected route from? The next address is R3. How to access your subsequent access network devices. Students, so the EIGRP boundary router, under default conditions, has two features. I will not be queried, because it's useless to find me. I don't have any other paths. The second feature, under default conditions, I will only announce my self-originated routing entries. I only tell you my directly connected routes, my self-originated directly connected routes to you. Tell you, and other routing entries I won't announce. So suppose you see, just now, we made R2 our EIGRP Stub Router. R2 has become a stub. Let's look at R3's routing table now. R2 has become a stub. Go to R3's routing table and look, Show IP Route. You see, now there's no announcement from R1 about these 100-watt details. All routes are gone. Why? Because R2 has become a stub router. And as a stub router, we will not become a target of queries. And I will only announce my own directly connected network routes to neighbors. The routing entries I learn, I will not send out. I will only announce my own directly connected and my own announced summarized. I will not announce others. This is the second feature of our stub router. Under default conditions, we only announce directly connected and originated. Then, doesn't this pose a problem? We made R2 a boundary router with the purpose of limiting the scope of our network queries. The scope has indeed been limited. But look, since R2 has become a boundary router, due to the features of a boundary router, now I only announce although I can receive these EIGRP database entries. I myself can access them. But now, I will not announce to other neighbors the database entries I learn. I will only announce my own directly connected routing entries to our neighbors. So in this way, look at the devices behind. Isn't it unprotected now? We no longer have roots, do we? Isn't it unprotected against someone setting up hosts in the 100 network? So this is something students need to be aware of. The default situation of EIGRP's stub router. Students must pay attention. Of course, we can configure it because these two are given to us. We can configure it. How to configure? When configuring EIGRP's stub, EIGRP stub, hit a question mark. We can choose, for instance, after our EIGRP becomes a stub router, we only announce directly connected routes. Press enter, show running config, section router EIGRP. After we become an EIGRP stub router, we only announce our own directly connected routes. Even our own summaries, we do not announce anymore. Even the summarized routing entries we've learned, we do not announce anymore. Students, I apologize, I was too hasty earlier. I missed something here, I wrote something wrong here. It's not just our own summarized routing entries, but also the school's summarized routing entries we can still announce. I made a mistake here, I wrote something wrong here. Students, please take note. After typing this command, for example, we summarize no shutdown. On R1's 0 interface IP summary address, EIGRP 100 EIGRP 90, then 100.1.0.025.25.25.2.0, then R2 has become a boundary router. So now I cannot be queried. Secondly, I also don't need to announce the learned routing entries anymore. I only announce my own directly connected, then show IP EIGRP topology, so many database entries. Then I've learned many database entries, such as those from R11. 1.1.3.0, such as those from R1100.1.0.0, but then I only announce my own directly connected on R3's side, show IP route, then on R3's side, then only saw 172.16.0.0, only saw R2's directly connected routes, only saw the directly connected routes announced by R2. Of course, that's possible. We type another EIGRP 90, EIGRP stub with a summary, called connected summary. We can announce both our self-originated directly connected routes, and can also announce those we have learned, or say our self-originated summarized routes. There you have it. Now we wait for it to reestablish the EIGRP 90 relationship after resetting. Look at its routing table. It just started. Sorry, it's quite slow. It seems only to have its self-originated. I didn't delete it wrongly. Darn, I've confused myself. It's self-originated. Shouldn't have been deleted. I felt something was off when I spoke earlier. This summarized route, I remember, similar to what we will discuss with BGP, such an aggregation. Got mixed up. So on the EIGRP side, students, it defaults to connected summary. Only can announce its self-originated directly connected routes and its self-originated summarized. Even if it's R2's school summary, I won't announce it, it's very strict, but we can adjust it. Look at EIGRP stub, because boundary routers are special. We previously used R3 as a boundary router. We'll demonstrate. I actually only need to announce my own directly connected routes. In this way, our routers will have our directly connected network routing entries. Basically, it's our network's boundary that needs to be configured. Features of the boundary router need to be configured. But we can still do this. For example, only announce the routing entries we originate, and our directly connected, our self-originated summaries. We can also add something, receive only. If we use receive only, it becomes quite special. With receive only, it's simple. I become a stub router, and then I don't announce anything. Let's get this out there. These characteristics all passed on to the stub's characteristics. Then only announce your directly connected routes. Announce your summarized routes. After becoming a stub router, then only receive routes. Don't send out any routes. For instance, if we now set R2 to receive only, I only receive routes now. I'm not sending now. Show IP EIGRP topology. Then I can learn the database entries, learn the routing entries. But let's go look on R3's side now. Show IP route. We can't see anything about the 172 anymore. They're all gone. Students, R2 is now only receiving routes, not sending any routes. Receive only. It truly becomes a boundary, not even announcing directly anymore. And redistributed, we only announce the redistributed routes in the database, and only announce our own database, our self-declared static routes to the database, declared into the database, in the database. Static routes, right? Students, these are the characteristics of our stub router. You can choose freely. As a boundary router, I will not be queried. I can also filter out some unnecessary routing entries. Then we can, of course, make adjustments. For example, in that case, it's perfect. I want the routers below to be able to learn a particular routing entry. What should we do then? This is what we need to consider. Think about it, no matter now whether it's R2, how we choose. We already have direct connections, already have summaries. Like, after adding direct connection summaries, we discover that actually for R3, I still can't learn any routing entries. Like, on this side, R2, even though we've added a stub, even added a summary, that connected summary, still, R3 learns no entries. Those routing entries, R3 can't learn any. Because for us R, I have now limited the query range, but I also carried the characteristics of a boundary router. So I very rarely pass through routing entries. This is both an advantage and a disadvantage. What should we do then, students, right? Look at this thing called a leak map. So, the leak map, students, we call it route leaking. Route leaking. After we become a boundary router, now we don't pass any routes, but we can choose boundary router. Basically only passing direct connections. Only passing those we are aware of. We can leak some specific routes from my database. Becoming a boundary router can greatly reduce the number of routing entries needed by the subsequent devices. We can also leak out the necessary routing entries for the subsequent devices. This is our leak map. The leak map requires some specific components which are quite unique. These will definitely be used in our future network studies. EIGRP Stub. What exactly is a leak map? It has a name. The name of the leak map, let's introduce what it is. In our future networking studies, it's an indispensable tool known as the route map. In Cisco's context, it's called a route map. Huawei and H3C refer to this tool as route policy, meaning routing strategy. In Cisco, we call it a route map, which does what exactly in routing? Mapping, which means matching or mapping a table. With this tool, we can manage a variety of data traffic and various routing entries within the network, as well as different parameters, to manipulate the attributes of routes and data. It's a very powerful tool, students, that we can use to adjust routing, to perform a series of operations on data. It's extremely versatile. Previously, we learned about a tool called distribution lists, which are limited to being used with access control lists. These can filter or allow matched routing entries, which are just the beginning. They can only interact with access control lists, targeting matched routing entries for filtering or allowance. Sorry, this part here, the distribution list, right? We filter and match routing entries, but in our upcoming studies, we'll find that distribution lists can also interact with route maps. Route maps can be used to manipulate operations on tools we will learn about in the future, like the pre-list. Regarding the tool, our distribution lists are mainly used to filter routing entries. They are primarily for routing entry filtering. That's the sole function of our distribution lists. Then our route map, we can use it for matching, setting attributes, and also for filtering. Its functions are very powerful. Let's first introduce how to use it. Students, how do we use it? We go to RSR, route map, a mapping table for routing, a tool for routing matching. You can give it a name. This name you can choose freely. We suggest students use a series, easily recognizable, to distinguish different route maps, labels that clearly show what the tool is used for. Don't choose names randomly. It might become confusing. So, how should you write it? For example, route map, we're now setting up a routing line, then call it leak map. Leak map, abbreviate it to leak map. Our route map, its name is leak map. Name it leak map. Hit the question mark. Then you can allow, you can deny, you can freely filter. Kind of like what? Like an ACL, right? To permit matching for allowance, to deny for rejection. For example, when we permit what's inside for students, a sequence number, a sequence number. So this sequence number, you can specify it. You can specify it freely. I suggest students start from number 10. Inside permit 10, enter, this thing is somewhat like what, students? Do you remember we talked about a named access control delegate in NA? IP access list? What standard, like we named it this standard access control list. Inside, we mentioned that inside each list, we use a number to order the commands in our list, like permit, like 1.1.1.1, deny 2.2.2.2, like permit 3.3.3.3. When we default to writing, like when we create a standard access control list, show access list, a standard access control list named A, it uses numbers to order the commands inside our access control list, to sort them in an orderly fashion from smallest to largest. So when an access control list is called, it's also called according to the sequence number size from small to large sequentially. So our route map is similar, creating a named routing policy document. It uses numbers to effectively order the command lines, very similar to our access control list. So on the R2 side, we can create such a map, just called what? LM. We go to permit 10, numbered 10 inside. We can write its statement, right? But we extend our access control to directly what? Permit 20 deny. Well, on our side, we enter a special interface to configure this numbered command line statement interface. Special under this interface to configure. You can do what? For example, we can go match our routing policy called leak map. We can match a lot of content. As you can see, we can match many elements, such as tags, such as IP, such as what is an IP access list, addresses. We match them to our access control lists, and we can also match packet sizes, the size of our packets. This traffic, unlike our access control lists, we can only target routing entries or, say, a particular host. We match the source IP address at the network layer, matching against the data network, or matching the prefix and mask of the routing entries. This is the main function of our access control list. And our route map allows us to match a lot more content. All these things can be matched, and of course, we can set many things, such as settings for matched content. We can set parameters for our data traffic, set parameters for our routing entries. There are many uses, so here we use it for matching. After we just wrote the route map, what do we use it for? Matching the matched. So for example, we are going to as R2, then I as our router, a border router. I hope my border router, under normal circumstances, can only announce directly connected routes, and the summarized routes that I originate myself, I also hope I can let them pass out. For example, being able to pass out the summarized route 100.1. 0.0/22 from my own database. Also, let it pass out, leak out, right, students? So how do we do it? We can write an access control list. So access list 1 just wrote 1, 10. We match it. 100.1.0.0, this routing entry, as R2. Then we use this standard access control list. We go to match routes. Students, access control list to match routing entries, to filter routing entries, right? We match up to 100.1.0.0. This routing entry, permit, Right, let it pass. So in our route map, at this time our access control list, this permit is for matching. We match up to 100.1.0.0. This routing entry. Just now, the route map called LM, we number it 10 inside. Permit, let it pass, inside 10. What are we going to do? Match up our IP address, our access control list inside 10, the one captured this 100.1.0.0 routing entry. Go like we are now putting on a doll. What doll? We use an access control list 10, match out the 100.1.0.0 routing entry. Then use our route map LM, it's statement number 10, also a statement number 10. When we match this access control list, made a doll, access control list matches routing. Our route map matches the access control list. Now our route map just matched up. Our access control list 10 captured 100. 0.0 this routing entry. So we can use it in our use it in, let me put it this way, show run section list and map. Grab it like this, because it's better this way. It also looks a bit clearer, like this. And then use the route map. We grabbed the routing entry, so now we can use leak map routes leaked here at R2. So as an EIGRP Stub router EIGRP 90, EIGRP Stub, we default to only announcing our direct routes, only announcing the summarized routes we originate. We can add I'm going to announce what else? Leak map. I let the route leak out. Leak map. We call this route map called LM. Calling our route map LM, so now our EIGRP border router. Then we can let pass our direct, our summarized, and our routing leaks. This mapping table in which matched leak map, we name this route map LM. In this routing policy matched 100.1.0.0. This summarized routing entry. It's a bit complicated, students, isn't it? You match a routing entry with an access control list, then use a route map to capture it. Our access control class list, insistently use a route map to match this item, then, teacher, can't you directly use a route map to match routes? That's not okay. Our route map tool is powerful, but each craft has its master. The work of matching routing entries is left to our access control class list to do. Then we specifically target your list, your packet size, your various parameters to do matching. Specifically targeting these contents to operate, each craft has its master. Do what you should do. I go to match inside to match you, then target you to operate, then specifically use a route map to match out. We just accessed control, inside captured routing entry, use leak map to do leaking. Go. So now right. As R2, then I can take the route map inside. I let it pass out. Still the access control list inside. Actually match this. 100. 0.0 routing entry. Then you see R3's sideshow IP route. Originally we couldn't see anything, but now you see we can see 100. 0.0 this one. Leaked out summarized route. Friends, so this is our EIGRP Stub Router. Then our main feature, as well as our such a stub router, routing leak knowledge point. Any questions? Any questions, students? If there are no questions, students, then congratulations to everyone. We have basically completed most of the EIGRP topics. We have basically completed all of the knowledge points. These knowledge points, we have completed all. Then next class, we will start our comprehensive EIGRP experiment. Okay, students, any questions? Wait a moment, let's chat. Wait a moment, ask questions. Students, who is Liu Xiang? No problem, right? No problem. Let's take a quick break. Rest for a while. We will start the EIGRP comprehensive experiment later.